Hello, I'm Jack. Welcome to my channel, Practical Programming with Dr. Su. In this video series, you will learn everything you need to get started with wgpu graphics programming in Rust. In the last video, I explained how to build a simple light model in wgpu. The example code in that video was very involved. In this video, I will show you how to use this light model to add lighting effect to a 3D cube, as shown here. This will be a much shorter and much simpler video compared to the last one. As we discussed in the last video, to add the lighting effect to a 3D object, we first need to calculate the normal vector on its vertex. For a 3D cube, calculating the normal vector is straightforward. As shown here, this is our 3D cube. Each face has a unique normal vector. For example, the front face here, we have 0, 0, 1, the normal vector. That is just the point, a positive z direction. For the right face, it is just a point to the x direction. That is 1, 0, 0. For the top face, we have 0, 1, 0. Just pointing to the positive y direction. In the same way, we can specify the normal vectors on the other faces. Note that the length of the normal vector needs to be normalized to 1. As long as we have the normal vectors, we can then use the light model built in the last video to calculate the light effect for our cube. Here, we will use the git tool to clone the source code used in the last video, and then make corresponding changes to that source code to build the project used in this video. Now, let's start Visual Studio Code directly from Windows Start menu here. This is Visual Studio Code interface. Now, let's start a new terminal window. Let's cd into code folder. In this folder, create a new folder called wgpu10. Make a directory. And then cd into this new directory. CD. We can then clone the source code used in the last video with the command git clone wgpu09. After this command, leave a space and a period. This will place all our source code in the current folder. Run this command. We can check direct. You can see all the source code is indeed in the current folder. Now we can open this folder from Visual Studio Code. Open folder. Code wgpu10. Select. Here contains the source code used in the last video. In the last example, we have implemented the light model in the cedar.wgsl and the common.rs file. Here, cedar.wgsl and common.rs file. In this video, we will use this light model to add the lighting effect to our 3D cube. As we discussed in the last video, in order to calculate the light model, we need to know the normal vector at each vertex on the face of the 3D object. Now, let's add the normal vector data to the vertex data of our cube. From src folder, open vertex data.rs file. Here we have a cube position and a cube colors. Now we need to add a new function called cube normals. So we need to add the normal data here. This is cube normal methods. Here you can see for the front face we have 0, 0, 1. That's the point to the positive z direction. For all vertex have on this face have the same normal vectors. So all 0, 0, 1. For the right face, is pointing to the positive x direction. That's why it's 1, 0, 0. All vertices on this face have the same normal vectors, and so on. Now we can save this file and close it. Next, we need to make some changes to the min.rs file. From src folder, open min.rs file. And here we need to replace its content with the new code. Since most code for the render pipeline and render path are already included in the common.rs file, so here the main.rs file becomes very simple. You can see we first introduce several the modules from different Rust files. First is the common module from the common.rs file, in which we implemented our light model. Another one is the vertex data module from the vertex data.rs file that contains vertex data and normal vector data for our cube. And the third one is the transforms module from the transforms.rs file, which includes the code for wgpu initialization and 3D transformations. Next, we define a vertex function here that converts the integer inputs for the position here and the normal vector data from integer I8 convert to F32 floating point numbers. We then define another function called create vertices. Inside this function, we first generate the position and the normal vector data by calling respectively the cube positions and cube normals functions. The create vertices function returns the vector of the vertex structure that was defined in the common.rs file. Finally, we define our main function here, which is very simple because we place most code to the common.rs file. So we just create vertex data and light data, and then use this data to execute the common run function. Now we can save this file. Now we can run our application in the terminal window with the command cargo run. Here is our 3D cube with a red color and a white specular light. You can see the speckled spots here. We can make changes to our light parameters. For example, we can set diffuse and specular intensity to 0 and set ambient intensity to 1. So here we close this window and set this color, the intensity. The AI means ambient intensity, we set to 1. And set D as diffuse intensity to 0, and S as specular light intensity to 0, rerun this application. This is the results. You can see now our cube looks flat and has no 3D feature. So now let's change it back. AI to 0.2 and DI to 0.6. I said 0.3. Now we can also change the diffuse light and the specular light color. The color here is for the diffuse light. For example, we can change it to green, 0, 1, 0, 0. This is green. And for specular light, we can change it to the yellow, for example, 1, 1, 0. So we can rerun this application. You can see we have a cube with green color and a yellow specular light here. Now we have completed this example. In next video, I will show you how to create a 3D sphere with lighting effect. Thank you for watching.